Okay, so now we're talking about limacons. And so this kind of, it starts, goes up like this, comes around, goes down, comes back out, comes back around. And so this is when A over B is less than 1. And then you get something like this when A over B is equal to 1. It's called the limacon. I think it looks like a lima bean. Okay. Then this one is so this one is 1 less than A over B less than 2. And then it kind of flattens out. And this is A over B greater than 2. Okay, so that's what the limacons look like. Okay, so now what we want to do is in this, we want to talk about how to graph some of these things because we're going to do areas and integrals and stuff like that with these. Okay, so the first thing is, let's look at symmetry tests. All right, so the test for symmetry. All right, so the test for symmetry, there are 3 tests. Okay, so that first one is symmetry about the x-axis. And the way you know something has symmetry about the x-axis is if the point r theta lies on the graph, then the point r minus theta or minus r pi minus theta also lies on the graph. Okay. So that looks like this. Okay. So whatever your, oh, come on now, I don't want that. All right, thank you. So if the point, so here's the point r theta, then the point, this point down here, which is r negative theta, or it could be known as minus r pi minus theta, will be on the graph. So so for example, the limacon, all of those limacons here with the cosine are symmetric about the x-axis. So let's take one. R is equal to A plus B cosine theta. Okay, so I'm going to put in R and negative theta. Maybe I did this wrong. I think I graphed this. I think these are the signs. Let me see. If theta equals 0, I think I graphed the sign. Let me go back. I think these are the signs. And I'll tell you why right away is because I can see that the cosine of theta is not symmetric. Okay, so let's try it again. So let's consider this. I'm sorry. I think that was right. I do think these are the cosines. All right, let's do it again. So R is equal to A plus B cosine theta. That's the original. And let's check R. So if I put in R is equal to A plus B times the cosine, and now I put in minus theta, but the cosine of theta is the same as the cosine of minus theta. So therefore I get R is equal to A plus B cosine theta. So I recovered it. So therefore they both are on, it's the same graph. Okay, let's try a second one. Symmetry about the y-axis. Okay, so symmetry about the y-axis. So if the point r theta lies on the graph, then the point r pi minus theta or minus r minus theta lies on the graph, also lies on the graph. So what does that look like? So here's the, so again, I'm gonna draw another one of these. And so now I want the point r theta. So the point r theta is here. And symmetry about the y-axis would put that point also on the graph. And so that would be, that point is either r pi minus theta, or it's the point minus r minus theta. Okay, so let's think about this. So here's an X. Let's consider So for this one, I can go back and draw a limacon and see that it's going to be symmetric about the x-axis. That's what I mean. Whatever is happening, it's doing the same thing on the top as it's doing on the bottom. Okay, so symmetric about the y-axis, let's consider r is equal to a plus b sine theta. Now, what does that thing look like? Well, that thing might look like this. So it's going to be symmetric about the y. So let's see. So this is my original. And so I want to take, and let's see, let's try r pi minus theta first. So we're going to put in r, and then we get equals a plus b times the sine. And now I'm going to put in pi minus theta. And if the equation comes back again, then I know it works. Okay, so I need to see whether the equation comes back again, then I know it works. Okay, so let's see what we get. So we get r is equal to a plus b, and the sine of that is the sine of pi times the cosine of theta minus the cosine of pi, the sine of theta. Okay, so r is equal to a plus b. The sine of pi is 0 times the cosine of theta minus the cosine of pi is -1 times the sine of theta. And it works. So I get r is equal to a plus b, and that's sine theta. So yes, that's symmetric about the y. So it's recovered. So they give me the same equation. Okay, and then the last symmetry is symmetry about the origin. Okay, and that says if the point r theta lies on the graph, then the point minus r theta or r theta plus pi also lies on the graph. Okay, and so this is the third symmetry. So here's the point r theta. Okay, and the point minus r theta, which is back down here, is symmetry about the origin. So this is the point r theta. And then this is the point minus r theta. And then this is the point, or it could be called r theta plus pi. So let's consider one of those flowers. So one of the flowers was r is equal to a sine of 2 theta. So if you remember, that was a rose. Okay, and it should be symmetric about the origin. Okay, if you remember, it went like so that one should be symmetric about the origin. Okay, so let's try it. So we start with r equal a sine theta. So I'm going to put in minus r. So let's put in minus r. So I get negative r. Okay. Is equal to a sine of 2 theta. So this gives me minus r is equal to a sine 2 theta. And that is not the same equation. So that's a problem. But it's possible it could be called by the other, it may be called by the other point. So let's try the other point. So let's try r. And I forgot this is supposed to be, this was theta. Okay, so let's try r. Is equal to a sine of 2 times theta plus pi. So maybe it works now. So one of them should work. It has to, because it's symmetric. So one of them has to work. So let's see, we get r is equal to a, the sine of up. I get the sine of 2 theta, the cosine of 2 pi, plus the cosine of 2 theta, the sine of 2 pi. So I get r is equal to a. I get the sine of 2 theta. The cosine of 2 pi is 1, plus the cosine of 2 theta. And the sine of 2 theta is 0. So I get back r is equal to a sine 2 theta. Oh, and it does work. Yay. One of them had to work, because I know it was symmetric. Okay. So graphing can be challenging when we are trying to figure that out. Okay. All righty. So in this section, we want to look at arc length and area for polar curves. I am going to start with a derivative first, so we can do the derivative. So let's start with the slope. So the slope of a polar curve. Okay, r is equal to a function of theta. All right, is given by dy dx, just like before. It's still dy dx. Okay, still dy dx. But we have to write this as dy d theta divided by dx d theta. Okay, now this requires a little bit of work, okay, and this assumes dx d theta is not equal to 0. Otherwise, it's an infinite slope. Okay. So let's begin with x is equal to r cosine theta. So that then implies that x is equal to f of theta times the cosine of theta, because r is f of theta. And y is equal to r sine theta. So that implies that x is equal to f of theta times the sine of theta. Okay, so now we got a little work to do. Okay. So dy dx, I got to do dy d theta first. So whoops. This is supposed to be a y. So dy d theta says, take the derivative of f multiplied by the sine of theta. Then take f of theta and multiply by its derivative, which is cosine theta. Okay, so that's the numerator. And the denominator says take the derivative of f multiply by the cosine of theta, and then take f of theta and multiply by the derivative, which is minus the sine of theta. So that's how you find the slope of a polar curve. Okay. So find, oh, this is an example. Find all points on the cardioid r is equal to 1 minus the cosine theta, where the slope is 0. Okay. Actually, we should do, actually, let's make it more exciting. Let's do the cosine, this is the sine. I hope I can solve this. I haven't solved this problem. All right, I just made this up, so let's see how this works. It may give, hopefully it'll give us something that works. Okay. So f prime, so f of theta is 1 minus the sine of theta. So f prime of theta is equal to minus cosine theta. Okay, so therefore, if dy dx is equal to 0, that implies f prime of theta sine of theta plus f of theta cosine theta is equal to 0 and f prime of theta, I don't have enough space, f prime of theta cosine theta minus f of theta sine of theta is not equal to 0. So the numerator is 0, but the denominator is not. So let's look at the numerator. So f prime is negative cosine theta times sine theta plus f of theta, which is 1 minus the sine of theta times cosine theta. And that has to equal 0. So let me make sure what I have. I have Anaya, are you following what I'm doing?
Yes, I'm taking notes as we speak.
Okay, so I want to help you get some comprehension while we're taking notes. So I'm gonna not just throw it out there, but I want to go through it. Okay, so remember before when we did dy dx and it was a function of t, it was y prime of t over x prime of t. Well, now because we're in polar coordinates, everything's in terms of the parameter theta. And so y is r cosine theta, but r is now some function of theta. So we have to put everything in. So here r is 1 minus sine theta. F of theta is then going to be 1 minus sine theta, and its derivative is negative cosine. So when I put this in here, in order for this to be 0, the top has to be 0, but the bottom can't be 0 at the same time. Otherwise, we'll have a cusp, and we don't want a cusp. Okay, so I put in f prime. That was, so f prime was negative cosine. And then I had sine. And then f was 1 minus sine. And that gets multiplied by cosine. Okay, so now I get negative cosine sine theta, another negative cosine sine theta. So I get minus 2 cosine theta sine theta. And then I get plus cosine theta is equal to 0. Okay? Because I have negative sine theta, so that's negative 2 of those. Okay. So let's factor out cosine theta. And we get negative 2 sine theta plus 1 is 0. Okay, so this thing has a horizontal slope when cosine of theta is 0, and when the sine of theta is equal to a half. Okay, so the cosine of theta is equal to 0. So that says that theta is equal to pi over 2, or 3 pi over 2. And then the sine of theta equal to a half is pi over 3. That is wrong. That is pi over 6. What am I doing? The sine is equal to a half? Sine is the short one, pi over 6 and 5 pi over 6. Now, I can tell you, we can knock out, you can just verify. But I truly believe that f prime of 3 pi over 2. Well, let's see. What does this thing look like? Let me draw it real quick. R is equal to, what did I say? I had 1 minus cosine theta. So this one, no, I said 1 minus sine theta, right?
Yeah, I was about to say that.
Okay, thank you. Okay, so this one looks like this. Okay, so when theta is pi over 2, I clearly see that one. That's this. Oh, yes. Okay, so here is theta equals pi over 6. I'm gonna get that one. So when, let's see, let's try it real quick. When theta equals 0, so what did I have? R is equal to 1 minus the sine of theta. So when theta equals 0, I am at 1. So when theta equals 0, I am at 1. When theta equals pi over 6, why am I confused? Resume recording. There we go. Okay, it's back. Okay, so now the area is the limit as n goes to infinity of the sum k equals 1 to n of 1/2 f of theta k squared delta theta k. Now, I don't know who your Calc 1 teacher was, but this whole thing becomes the integral from alpha to beta. And then we get 1/2 f of theta squared d theta. And that's the area. Okay. Or you may see integral from alpha to beta to 1/2 r squared d theta. Now that looks like what we did in Calc 1. Okay. Find the area of the region. What in the world did it do? Okay, I'm sorry. It moved my stuff. Find the area of the region bounded by the Lima sign are equal to 1 minute, are equal to 3 plus the cosine of theta between 0 less than equal to theta less than equal to 2 pi. Okay, so this thing looks like this. So R starts off at 0 and it just goes all the way around to give us the area. All right, so I'm going to stop here. A is the integral. So it's so notice it's symmetric about the x-axis. So if I find the area at the top, I don't have to find the area at the bottom, so I can use symmetry. So it's 2 times the integral from 0 to pi. So I only have to go from 0 to pi of 1/2 r is 3 plus the cosine of theta squared d theta. Oh, I'm missing a 2. 3 plus 2 cosine theta. There's a 2 in here. This is 3 plus 2 cosine theta. And there's a 2 in here. Okay, so we're going to stop there.